Well, good afternoon, everybody, and welcome to the next DGage podcast. Today, I'm going to introduce you to one of the team who led the introduction of the National Gauging Database, which I was involved with, but who more recently has been Network Rail's head of topographic survey and is currently the past president of the Chartered Institution of Civil Engineering Surveyors, isn't it, Chris?
CICES is the easiest way to remember it, David.
Yeah, I'll still get institute and institution messed up. I usually get it the wrong way around. But anyway, welcome, Chris, and really good to have you on board for this discussion, which I like to take us into some of the areas that will be familiar to you, and certainly some of the areas that are giving us interesting discussions and debates in terms of handling of gauging data, particularly. The first thing I wanted to talk to you about was in terms of the technology that we're using. So we've kind of lived with 19th century measuring systems for quite a long time in the field of gauging. You can remember the sort of piece of wet string and a pole that you poke up and measure tunnels with. We've got rid of most of those except for the standard platform gauge, which we still seem to love. It's just not been superseded by modern technology yet. What's your views on that? When do you think that might be a thing of the past?
Well, I think platform gauges, in my estimation, have always been a significant issue in terms of their calibration and their consistency of measurement. I can remember if you leant on a platform gauge, you could get a different answer according to what you thought you might need. And clearly that I don't think is a sustainable way to measure platforms. Of course, the advantage of them is that they are relatively cheap compared to many of the modern systems. But of course, different operators read in a different way as well. So there are some difficulties associated with that. And of course, the repeatability is important. Now, the results of any gauging exercise, as you well know, are dependent on the smoothness of the surface of the structure or platform that we're measuring to. But more recently, tools like a laser sweep have replaced standard gauges. But again, the consistency of these is open to question by some, unless some kind of item is placed on the structure to measure to so that you've got a consistent surface. But in terms of modern technology, I think track measuring devices, or surveying trolleys, as perhaps others would prefer to call them, really are the tool for doing platform gauging now. And they would have something like a disto attached to them that measures directly to the surface. And they can be pushed through so that you get a radial measurement as well on the more sophisticated ones, or you can do them at individual locations. So that would be my chosen method for doing platforms on an ad hoc basis, and I think would probably give you the most consistent results. But looking to the near future, laser and LiDAR systems that are mounted onto road rail vehicles or onto train-based systems will be the chosen tool, as these can be run regularly and highlight areas of concern that then closely looked at. Because the issue is, in many cases with gauging, is that the vast majority of places are fine and there are a few that need a closer look at. And it's those where our efforts need to be concentrated when we're thinking about clearing a route for new traffic. But by far the biggest issue in comparing results from different systems is ensuring that exactly the same place on the surface is being measured to. I think this is fundamentally one of the biggest issues that causes so many variations. So then we get back to the skill of the operator in using them. However, what this doesn't do is account for the understanding and knowledge that the people using and analysing the data have. Unfortunately, the use of statistics nowadays is something that we can't ignore. And many railway engineers are really not very familiar with it in terms of the way in which you have to look at a measurement process. And it's the same with any measurement process. It doesn't matter whether you're using total stations or any time you measure something, the results and the accuracy of the results are associated with statistics. And sadly, the knowledge of that is not very good.
Interesting. So from that, I'm really taking it that you're very much of the opinion that platform gauges days are numbered. And let's hope that we do move on to the sort of more sophisticated systems that as an industry, we can actually start to use the data from some of the systems that are up and coming and perhaps consign the platform gauge to where it belongs. So,
well, that would certainly be my view. I think I think the time for the platform gauge has long since passed.
Yeah. So what do you think in terms of just general structure gauging? Do you think we'll see a new generation of structure gauging trains? Obviously, we've been through one or two in the last decade or so. Or do you think the survey industry generally has moved on to be able to use more general survey technology to satisfy these needs, particularly in the area of, say, tunnel gauging?
Well, personally, I think it's unlikely we're going to see another generation of structure gauging trains specifically for gauging. There are now many generally available surveying tools, such as laser and LiDAR-based systems, that can be attached to track measurement devices, road rail vehicles, or of course trains. I mean, RELA is another example of such a system. But one of the key things is understanding the speed of passage that is required on the train, because if you have a rotating system, there will always be a gap between the point cloud that you have in your helical scan. And as a result, you need to be sure that that is not going to miss important features. So the passage, I would see, needs to be at a relatively slow speed so that you don't have gaps in the scan. And the same applies to platforms, lower sectors and upper sectors in gauging measurements. And then it comes down to the processing software that's used to rationalize the point clouds. The measurements to the surface, of course, normally are taken as a 5-meter chunk and then rationalized to give the worst case scenario. That's certainly the way things work using software like ClearRoute. And therefore, an understanding of how that rationalization takes place is really important. And in a way, that is getting more into the realms of where we're going in much more automated processes. I think as far as tunnels and other softwares are concerned, there are clearly going to be obstructions sometimes, things like weeds growing on the side of walls and things sticking out like small nails. There is a need for those to be removed from the software, from the point cloud, before any analysis is done. And this surely, again, must be an automated process. So that's where I see that going. I think general surveying technology now is more than capable of satisfying the requirements for gauging. And I think we've always been extremely conservative in the railway as to what we will accept and what we won't. And I clearly understand that our gauging engineers have safety as a major requirement, and I wouldn't dispute that. But I think the time has come now where we've got to be a little more clever in identifying the tools that really do give us consistent results and those which perhaps need to fall by the wayside.
That's interesting. I mean, it is quite interesting, the point you make about the odd bits and pieces that we pick up and may confuse with something else that actually really don't matter. So a piece of brushwood or something sticking out shouldn't be something that stops the train. It should be something that we should actually probably not have in the first place, or someone should take it away. But certainly it shouldn't be considered to be the same as an immovable object that is actually going to go in the path of the train that we have to go and move the track for. Very interesting point. Given these new systems such as point clouds and stuff like that, do you think that we'll be able to capture the detail and intricacies of the OLE system, things like steady arms and stuff like that, which might lead potentially to, say, an OLE equivalent to the National Gauging Database?
Well, I think that laser scanning is very definitely a tool that can be used to define overhead line systems. And of course, there are two requirements for OLE surveying generally. The surveying for the height and stagger of the wire, and then of course the structure detail itself. And in a sense, the two are quite different in terms of the level of detail that's required. We went to quite a lot of trouble in writing a standard within Network Rail for surveying for overhead lines, NR L2 TRK 3100 module 5. And that details quite clearly a lot of things that can be surveyed and the techniques that can be used for surveying them. Now, there's been a lot of talk about using overhead LiDAR taken from aerial systems to pick up the overhead line. And there was a lot of dispute not too long ago as to whether that was giving good results or not. And I think it depends on what is required in terms of accuracy. Quite often our engineers overstate what they require in terms of accuracy. Yeah. And I think we've got to be a bit more pragmatic about the approach that we take, bearing in mind the amount of work that it requires. Now, when it comes to overhead line structures, yes, you can get detail of those from LiDAR taken from above. And of course you can with oblique imagery. But I still believe that the most accurate approach is actually doing those from the ground. And it's possible to set up laser scanners outside of the area of safety, so 3 meters away from the track in many instances, where a good laser scan of the structure can be achieved. It may mean that probably 2 or 3, even possibly 4 setups have to be done. But if you really want the intricate detail of a structure, that's the way to do it, in my estimation. Now, the second part of your question is around whether we need an OLE equivalent of the National Gauging Database. I think my question would be, what purpose do you think that would solve? Because at the moment, of course, there are records of overhead line equipment, the type, etc., or for every type of installation that's been done. And of course, within the Network Rail's asset data, there are details of overhead lines and the type, etc. So I'm not quite sure what would be specifically gained by a database of OLE equipment. The only thing I could think of is that it would give us a standardized way of identifying each type of overhead line and all the features that every particular one has.
I think where the potential need has come up seems to be where we're trying to run TSI compliant trains in terms of pantographs on legacy infrastructure, and there seems to be doubt as to what exactly we have out there in certain places. And I think possibly a National Gauging Database of OLE data has been mooted to provide that sort of background, but of course it may not be that that's the right thing to do. Certainly a question that needs to be asked, I think, before someone goes out and sets out a multi-million-pound contract to survey the entire OLE infrastructure that we've got.
Yeah, it strikes me that the TSI is really looking very much at the height and stagger of as opposed to every structure.
True, but we do have the issue of the tilting head on the pantograph, which of course most of our OLE wasn't designed to accept. And I think where there's concern are things like, for example, does the steady arm potentially foul a pantograph if the pantograph is on full head roll in the wrong direction, for example?
Yes, I can see that. Yeah, as a potential problem. Yeah, it is an interesting one. That. And I think it's a case of whether the end result is that in certain areas you have to ban the rolling of the pantograph.
Well, exactly. That's an interesting thought. A sort of special TSI case, you're not allowed to do it. Yes. Trying to get more controversial, which clearly we are now. And moving on to these high density, point density measuring systems we're talking about. I'd like to move on to the subject of artificial intelligence. And what role do you think artificial intelligence might play in the removal of noise from this data? Because traditionally, it's always been a very labor-intensive process where someone will be clicking on points on the screen and taking them off. But clearly, as we're getting very high density measurements, we can't rely on that. So do you think artificial intelligence has got a role to play in this?
Well, I do. I mean, we touched on it earlier when we were talking about removing noise and things like weeds from point clouds. I think it has, and I think that needs to be automated now very rapidly. And whether that's true AI, I'm not sure, but clearly there is a role for that to play in these particular scenarios. In the survey world, artificial intelligence is becoming the norm in taking big data sets and actually creating imagery from them and lots of other deliverables for the client. And I think AI will continue to develop very significantly. It's used very much in things like the film industry, taking point clouds of scenery and even actors' faces and planting them on top of characters that are in games and films. So a lot of what you watch in films nowadays is not real, it's all generated by artificial intelligence. So I think it's a natural step that this will become more and more involved in the railway industry. But the interesting area is then when we start to look at what happens when something goes wrong.
Yeah, I think that's the crux of it, and probably something that we should maybe discuss and then leave it to our listeners or viewers to come up with some conclusions, perhaps post on our on the blog any points on it. But looking at the ethics of artificial intelligence, of course, we're seeing a lot happening in terms of that, particularly in terms of the what should an autonomous vehicle do if faced with a young child or a vicar in the road. Which one do they run over, for example, is the question that seems to be posed quite frequently. But I think when we start to look at this, we've traditionally been in a situation where the person responsible for dealing with data has a responsibility to make sure that they act competently in shall we say, processing that data. But we now getting to the point where you have to look at the artificial intelligence and say, one, what point do you put blame, for example, on the writer of an algorithm that's doing something, or if it's true autonomy, at what point do you blame the machine, or is it actually possible to blame a machine? So I'd be interested in your views on the ethics of this, and particularly in the case of survey information, where do you think we will go with it if there is a blame culture attached with it that relates back to a human somewhere along the way?
Well, sadly, whatever a machine does, it's always going to be linked back to a controlling mind that either wrote the algorithms or said to the machine, you will do this under a certain set of circumstances. I think undoubtedly one of the things that will be required if we want to use AI in its most comprehensive form is some kind of rewrite of contract terms. Certainly whether it's in an NEC contract or some other form of contract, JCT contract, for example, or the type of contracts that Network Rail let for their professional services, there's going to have to be some thought given to clauses that associate with artificial intelligence, because without that, it's very difficult for a supplier to hand on heart say, well, I did my best to provide you with this information, but I can't guarantee it's 100% error-free. Well, if that results in a train hitting a platform and derailing and people being injured, I think we would be open to question and would have a severe difficulties in knowing who to blame. Currently, of course, professional services contracts require some form of auditing of the results, or they should do, and any good client will automatically audit some of the results to check what's going on. So thereby lies the problem. Is the client prepared to do his audits, or does he just accept that what he's given by a so-called reputable contractor is appropriate for the purpose? Is it fit for purpose, to use the normal term? So it's very much an interesting area for discussion, I think. And I'm sure that I hope people on the chat room will come up with some interesting ideas, because I think it's something that certainly is worth exploring as to the way in which we should be going with it.
Yeah, thank you, Chris. I think that hits the nail on the head, really, because I think if we're not careful, we could actually hinder the development and use of some very good systems in the railways because of our traditional conservative approach to things, and basically just looking at saying there's too much liability on the person to even bother. And it's certainly something that I've been involved with in the sense of developing gauging software, particularly, that if you like, we do get to the point where people are pressing buttons, and if they come up with a wrong answer, then it's really down to the systems one has in place to say, this is how we've developed our software, this is how we've tested it, this is how we've proved it, that keeps me out of court. But I think the issue is that, as we go to more and more artificial intelligence systems, so in actual fact, the thinking is not being done by human, and indeed, it's almost as though it's not even an algorithm. It's a self-learning system, and I kind of think, are we almost at the point that was predicted in 2001: A Space Odyssey with HAL and its decision-making process? But I suspect that most people who are watching this probably wouldn't remember that film because it's too old and too far in the past. But it'd be an interesting one, and as I say, certainly a nice controversial thing to finish off this podcast with. So, Chris, thank you very much for joining us today. It's been great talking to you, and certainly good to hear your views on the topics that we've discussed. I'm sure we could go on for hours on this. That's usually the way of these things, but of course, what we do want to do is to keep it short and snappy. So what I'm going to do now is say thank you very much, Chris, and we'll sign off.
Thank you very much, David. It's been a pleasure to chat to you about these things, and I look forward to seeing what sort of response we get on the chat rooms. Thanks very much.
Thank you, Chris. Cheers now. Bye.